I'm hoping tonight will be really informal. As you can see, I just got off the plane from here, and so I'm hoping that this is going to be a really informal discussion, an interactive discussion too, because I'm going to give you an abbreviated version of the presentation that I'm going to be making tomorrow, and it's super abbreviated because I want to include you into this. Has anybody ever done a birds of a feather session? Has anybody participated in, we call it a birds of a feather session. It's where we get together. It's really an open Q&A back and forth. And so I'm going to try that with everybody here. So I want everybody to jump in and ask questions once I open the talking points. But I'm going to give you about a 10, 15-minute overview of what I want the discussion to be. And then I'm really looking for you to join in, because there's some stuff that I want to hear from you, and I want to learn from you about this as well. So as Attila said, my name's Geoff. I'm from Dell EMC. I am a test architect. I've been a software engineer for well over 30 years. Went into the test field about 10 years ago as we were starting to do our agile transformation. And so I was brought over there as a software guy to try and make nice between development and test. That was why I went over into that organization. But the reason I'm pointing that out is I'm a test practitioner. I'm not a data scientist. I'm not a big data person. So I'm looking at this all about AI and machines from what can it do to help us do our jobs, okay? So I know the title of this presentation is very provocative. What's our job when machines do testing? And I want to talk about that. So with all of the talk about AI in machines encroaching on jobs in industry after industry, it's time for those of us in engineering to really start to take notice of what that means for us, because we're all familiar with what we're reading in the headlines in about Amazon, in their warehouses and their distribution centers getting more and more automated with the bots. And the Tesla manufacturing facilities are almost 100% automated these days. And I don't know about you, but in our McDonald's and Burger Kings in the US, we're not talking to people anymore to order our hamburgers. We're going up to automated kiosks. They're getting replaced. And then just going through the airport on the way here, automated kiosks to do check-in, to do customs control. The lines were horrendous today down at the airport, but everything's automated, and if something is a glitch, we got to wait in another line. But as engineers, we've really been comforting ourselves by the belief that our knowledge worker jobs are immune from automation, from this full type of automation, really. If we admit it to ourselves, we really do believe that our jobs are not going to be fully automated. But could AI really start to take over some of the tasks that we do in our jobs? And if so, what are the types of tasks that AI might be better suited than we are as humans? And what are the things that humans are really better at that might be going on, and we might have a job going on? So for those of you that haven't started asking yourself, what's our job, or better yet, what's our job look like when machines do testing? Now's the time, right? We need to start asking ourselves that question, and that's what I really want to challenge everybody here today to have that discussion with me. So just a quick outline of our discussion. When we call this a birds of a feather, like I said, it's going to be very interactive. And I'm going to first set the context with a few slides. That's something, we're all in software engineering. We're pretty comfortable with this concept of test automation. We've been doing it maybe some of us longer than others, but for a dozen or so years. And so we're going to talk about it in the context of automation, just like we've been doing scripted automation and DevOps automation, and more as a tool to help us do our job. I'm going to share with you some of the early work that we've been doing at Dell EMC in our server division. I won't get too deep into it, but I just want to give you a couple of examples on it. And then we're going to open up this discussion, all right? So why automate? Why in our world of test do we automate? Because automation isn't free. Those of us that have been doing automation for a while know that the maintenance part of it is really expensive, especially when the UI gets changed and we have to go in and start from scratch. But at the end of the day, our product engineering teams are really put together to deliver and create new value, right? As part of that value creation process, though, once they've delivered that value, they have to maintain it. Right. All right, I'm on the right side. So, but they have to maintain it. But the really interesting part for us when we think about our jobs as engineers, the really creative and energizing part of that work is that value creation process during the sprints where we're working to understand new requirements, trying to figure out how we're going to get the mounting technical debt down. And we know that the best value creation is done in a highly collaborative environment. Everybody's moving towards that way. But there's this regular beat of interactions with our product owners, with our developers, and our testers, and the rest of all of our extended teams that we interact with. And that's where we're really creating the new value. That's that connective tissue of our team, of our agile teams. We are truly developing our software differently today than we did 15, 20 years ago. And that's where the human part comes in too. And so it's the other tasks, it's the regression testing tasks and those DevOps tasks that we've really been focusing on automating. That's the boring stuff. We can go do more of the fun stuff. So as testers and members of our product team, what we really want to do is start maximizing the energy that we're bringing to the team and the value creation. Let's deliver more features for our customers. And that automation plays a big part here because where we've got automated testing, we're applying that automated testing to ensure that all of the new feature that we created in the past still works, right? We spent time on it. It was important to deliver. Let's keep that healthy. Let's keep that value intact as we're delivering the new stuff. So we've been busy automating a whole bunch of stuff for the past decade, at least at Dell Emc. When we went from our waterfall transformation to our agile transformation, we started doing a lot more automation. And we got into the continuous piece with DevOps and getting our pipeline set up. But the interesting thing is, as we've gone through and started automating, there's a whole new set of tasks out there. And we're starting to call these cognitive tasks. Well, they're cognitive tasks in nature, and I'll talk a little bit about them. But these are additional techniques for us to consider in automating and let us go focus on the fun stuff and the value creation piece. We're going to be talking about cognitive tasks that we can automate with AI and ML, process orchestration. And when we start piecing a lot of this stuff together, and with our manual, well, I guess our mechanical automation, our test automation, and things like that, when we start putting these things together, we can even start getting into this autonomous self-driving regression type effort. But it requires a glue of this automating some cognitive tasks. So I'm going to skip this piece. All right, so as I mentioned earlier, our journey at Dell Emc it started about 10 years ago when we went from waterfall to agile. And when we did this, and I think this journey is going to be the same for a lot of organizations, everybody's going to be different. Everybody's organizational contexts are going to be at different parts on this. But when we went to agile, one of the very first things we realized was, holy cow, we just delivered a whole bunch of new value last sprint, and I can't keep up with the regression testing. So what did we do? We went and automated a lot of those tests. When we finished automating a lot of those mechanical tasks in our regression tests, we looked around. We now had a new skill set. We had this software development engineer in test skill set. So now we want to automate more stuff. Can we apply it to other areas? Sure. We can start automating the pipeline, automating the DevOps pipeline. And so as we start to look ahead, though, to AI and machine learning and analytics, and I bundle these things all into the same because they're all data-driven activities, With cognitive automation, we're talking about automating some deep think tasks that we do that are based on data. But there is a few different factors in play. Some similarities to what we just went through with Agile, scripted automation, and DevOps. As we go into cognitive automation, there's some similarities, right? Agile required, and we know it, required a huge process and cultural change within our organizations. That was a big change for us. For testers who were doing manual testing, they had to learn a whole new skill set. They had to get into Python and Java and start coding. And DevOps brought in another layer of new tools and learning into our test skill sets. But for cognitive automation, there are some new things that make it even more complex. The first one is data science. That's a brand new skill set for those of us in development and testing. And it's unlikely that any of us are going to have data scientists on our team. But there's more and more kids coming out of university with it. But more than likely, we're not going to have them on our team. Data is another thing. And data is the elemental resource of analytics, AI, and machine learning. And the capture of the data, the cleansing of the data, the keeping clean of the data, all of that stuff to make the data useful enough for your bots to work off of requires a lot of process change to keep it that way. And the other part that's really tricky is it's proprietary data. Not a lot of other people outside of your organizational context are going to know what to do with that data. They're not even going to know about your data. But that's probably the biggest one, is the proprietary nature of this. So what I'm saying here is it's a pretty big point. If you're thinking about it, and this, I want to hear from you on this, but if you haven't started thinking about it and you're kind of interested in machine learning, analytics, and AI in your testing environment, you need to be prepared that this could be a heavily proprietary and custom implementation, right? You're not going to find a lot of off-the-shelf tools. There's a couple. You're going to see a couple, and you may have heard from a couple folks today in tutorials, but that's going to be a small sliver when I show you the spectrum, because I want to show you a pretty broad spectrum of things. All right, so Jason Arbonne. Has anybody heard of the name Jason Arbonne? Okay, Jason Arbonne is a CEO of a company called Teszt&Tea. He's got a partner company here at the conference this week. Jennifer Bonine's going to be talking. She's in pinklion.ai, and they're co-partners. But Jason Arbonne is a pretty thought-provoking guy over in the U.S. test circuit. Interesting character. Love him to death. But at a conference that I was at earlier this year, he put this slide up. So because he's got bots. He's actually got off-the-shelf bots that he is using to do testing. And I'm going to talk about them in a few minutes. But what he's on one end of the spectrum that says, yeah, bots are going to take our jobs in 10 years. And here's how they're going to happen. In the next 5 years, the bots are going to be taking over all of our quick thinking tasks. What does he mean by that? He's talking about quick check diffs, quick performance deltas between this release and the last release. Things that you can inherently do, you can ascertain when you're doing them in seconds. Those are the quick thinking types of tasks that bots are actually starting to do. The next category is thoughtful, and I think he had this between 2023 and 2027. These are thoughtful tasks. These are tasks that it takes about less than 10 minutes for us to get done. Think of, they're more qualitative in nature. Think about generating tests, maybe doing some usability testing and negative and edge case testing. Things that we have to think about. They're a little bit longer than seconds, but something that we could probably nail down in 10 minutes. Then after that, in 2027, he's saying it's gonna dive into the contextual types of tasks that we do. The contextual types of tasks. What are those things, right? Those are test strategy and test planning, and maybe going in and doing exploratory testing, trying to understand and discern where are the weak spots of an application. And then, of course, decisions to deploy. That requires a lot of context. Those types of tasks are tasks that it requires us as humans, mere mortals, days, maybe weeks for us to do. And Jason is saying, yep, the bots will be able to do that in about 10 years. So, what I want to do is, I'm a little bit more pragmatic than Jason. So what I want to do is I want to walk you through what are some of the tasks that we do in our testing world. In our development world, this is across the whole SDLC. So there's probably hundreds of tasks that we do, right? I pulled out some things that I think will resonate with you. And I'm going to talk about 2 of them today, but there's a couple that I wanted to highlight. I'm going to talk about configuration matrix planning. This is super important to us because the group that I'm in, we're doing firmware development and software development and do the physical hardware testing. So we have to test, we actually have to have physical configurations in place. So we get, our config matrix gets really big. And I'm going to talk about that one in just a second. Another one that I'll talk about is the AI-assisted UI automation, and that's where I raised Jason Arbonne's in pinkline.ai. But there's another one that I didn't add on here that we're starting to look at, and it's really interesting because it gets into triage, putting bots in place to help us with defect triage, helping streamline the defect triage problem. And because we spend a lot of time, once we've automated all these tests, and if our dev teams haven't fixed them fast enough, we've got a pile of defects to go through. Can we get a bot to go through and mine through that data? And then can we also get a bot that goes in and pinpoints who I should redirect this test failure that we think is a defect back? Some really good opportunities for us there. So this is just to get some of the juices flowing for you. Well, I did have predicted defect root cause on here, but there was another one on here, and test failure diagnostics. All right, so I talked a little bit about the context at our organization. Big, so the number, I didn't say the number. So 465 trillion unique configurations. It's possible for us to go. Now, we have to go buy those systems to go test them. Obviously, we can't go buy that many systems, but this is one of those tasks that we take 2 of our leads for every platform, and we try and go plan out what's the right configurations to maximize our test coverage for our new features and the currently shipping features. Because we've got to try and make sure and give ourselves comfort so that we're not releasing stuff out to the customers. So it's a combinatorial nightmare for us. Now, this same thing probably applies to everybody. It's just at a higher level, right? Because we still have to factor in OSs, and we have to factor in browser configurations. For the folks in the mobile, you have to deal with form factors and the different OSs. So everybody's got a config matrix to deal with anyhow. For some, the config matrix is a little bit more precise than others, and it needs to be. All right, so what we've done is we've given we call them our assistants. They're our smart assistants because they're going off and doing some cognitive tasks for us that we don't have to do anymore. So this one, James Bond fans, 007, there, all right. So we call this one Q. So Q is the one that's going to go through and mine through a lot of our historical data. So Q goes through and takes a look at our sales configuration. What was our sales data on the prior generation of our configs? What were the unique configs that sold the most? And we go through all the way through those configs, and based on what workloads. We then take a look at what are the incoming new hardware requirements and firmware requirements for the hardware, because that's really important. What are the things that we need to test at the software firmware layer? And And then the other one is restrictions and configurations. There's some of the physical cards can't go in certain boxes. And so we have to deal with a whole bunch of that. Now, there's a whole bunch of other data sets that we can start to apply to make these assistants even more precise. But what do they get us in the end? What are we looking to get out of these things? We're looking to get efficiencies here in the form of buying us time. That's what we're all short on. We're all short on time. And so we're trying to buy back time out of our activities and let the bots go do some of that stuff where we spend a lot of brain power going through boring, medium data sets, trying to discern that ourselves. Bots are much better at that than we are. But the real value for us is going to be on when we need to replan a test run and we just don't have the time. We didn't get a new NIC card, or we got in a new firmware. It didn't come in time. The new feature didn't get delivered. What's the best available configs that we have at that point? That's what this helps us out with. So another one that we're starting to look at is the UI assisted automation. And there's a couple folks here I know at the conference that have solutions in this space that are very interesting to us now. Because a couple years, so when we first started from our agile to waterfall, or from our waterfall to agile transition, our testers, black box, manual, didn't know anything about the inside, so we went and automated the UI. At the UI level, we didn't even look at the APIs or anything, we just did UI automation. We re-architected the UI, and all of our automation percentages that we got up to like 65% went to 0. And at that point, our teams kind of recalculated and refactored and said, we've got to go automate at the API level. So we've been running with very little UI automation, most of our automation being at lower levels of the automation triangle. So when we started seeing tools like Retest and Teszt.AI and Pink Lion and Mabel, those things are starting to offer us the ability to get more coverage. Because there has been more and more business functionality that is seeped up into the UI above the API, and the only way you can test some of that is through the UI. And so we're now back heavily starting to investigate these types of tools. And I think you're going to have some of the folks at the conference talking about these types of tools. A lot of these are AI driven, and it gets us out, and the goal here is to get us out of the UI automation maintenance. All right, so this is where I am looking for folks, because I want to find out from you guys. We started down our path about 2.5 years ago, just going down this, making small investments in looking at AI as a way to automate some of our more difficult tasks, but deep think type tasks. And so what I've been really interested in is going to sessions like this, where there's birds of a feather, and finding out what other folks are doing. Are they doing anything? Has anybody in here started building bots to help, not scripting testing, but have you started building, and I'm going to include analytics models, it's kind of like a manual data-driven model, or machine learning bots. Has anybody started going down this path yet in your organizations?
We have mics, so raise hand, and I'm going to go to you and hand over the mic.
I know there's a couple people in here that have to say yes, but they're probably going to hold off for a few minutes.
Maybe those guys. Okay.
Yeah.
Just a second.
Okay, thanks. So what's the question?
So what I'm looking to understand is we've taken a couple steps now, and we've started looking at applying some of this bot technology or analytics or AI against our testing tasks. So you need to think about what type of tasks you might automate with AI or machine learning. So my question is, have you started doing anything like that in your space?
Yeah, of course, yes. We are working in the UI test industry, you know, and if you create test scripts for the UI testing, they can, you know, break many, many times, so you need to create a system which just helps a lot in that. And, okay, an example, if I create UI test with scripting, many times I need to find some selectors or some rules how my test will find a special element on the screen. And for that, for example, we invented a bot which can recognize the interactive elements on a HTML page, you know, and create the selectors. And I do not need to do that boring stuff, you know. Mm-hmm. This is one. Or the other thing, when we check the results of the tests, and you know, some results are real positive results, so there is a system error then, and some are just technical problems because the network was wrong or something similar. And if we need some statistical data because we want to show this data to the managers and I do not know, some other people, then we need to go through the entire automated test result step. And this is also boring.
Right.
So a bot can do that easily, I think, because if I just selected the real errors, then a bot can learn how I did that and can select the real errors later without me.
There's another one that our team didn't do it, but one of our sister teams did. So Dell and EMC merged a couple of years ago, and one of our EMC teams looked at the problem where we had a lot of test case failures, where they had a lot of test case failures, and the dev team wasn't responding so fast to the test case failures, right? They would fix a couple, but then they would have a piling on effect. There would be more that came out of that release. So what happens when they run that test automation the next day? There's a pile of defects that they found yesterday that weren't fixed. So how do they easily, that's boring. Because what they really want to go find is from this test run today, what do we think are the net new defects, right? And so what they did is they wrote some bots to go through and kind of fingerprint the test case failures and predict, hey, of the test case failures that we had today, we predict this batch as the net new defects. We think these are new defects. So that was really cool. It's fixing a symptom. You really want to go back to the root cause. Can you fix it faster, guys? But that's another type of a solution.
And the bot can do that.
And that's very helpful to testers.
Yeah.
Very helpful.
Or test case generation. This is a very similar thing. So if I have a finished state machine, for example, I can generate a lot of test cases from that. And the bot is much better than me because, for example, it takes 2 days for me, and I can find half of the test cases with my brain because it's boring and you know. But only a click and you have all test cases. If you created your finished state machine well.
Yeah.
Okay.
All right. Thanks. Who else? Has anybody else started going down this path yet? Is that Donnie? Yeah.
Yeah. Thank you. So Diony, myself and my colleagues at Ultimate Software, we actually went down this path. We started about 3.5 years ago. And really what we set out to do is to create these bots that rely on machine learning. And kind of the approach for the project, or one of the main goals, was to be able to send a number of bots, so say 50, 100 bots, what have you, and actually go and explore the application or the system under test for us and build a model, a finite state machine, of how to actually go from place A to place B across all of the different states in the application under test. So we were able to actually achieve quite a bit of progress there and use that kind of as a foundation to then start building test generation techniques on top of that were trainable. Obviously, there's still a lot of work to do there, especially with the Oracle problem, but that foundation allows us to essentially have this framework that we can start plugging in more and more types of testing to. So the key there, just last kind of statement, the key there is really just that ability to automatically or autonomously explore the system.
So your stuff, you had them going after some of the, what Jason was calling the, not the quick, it was the let me go back.
Contextual.
Yeah, not the contextual one. Thoughtful. The thoughtful, because the exploratory type testing. Mm-hmm. And so you guys you're actually walking through, what's the data set that you guys are using to walk through and do that?
So we're using kind of a combination. So we're using reinforcement learning for trying to find more and more states in the application autonomously. So one of the goals is to try to explore as much as possible with the bots. So the reinforcement learning does not necessarily have data. It just gets rewarded based on finding new information. And then there's also parts of the test generation systems that we do train it based on expectational things, like if you see required fields, then there's this specific way to test required fields, things like patternized. And then we also have started looking at implementing like boundary testing, equivalence testing, pairwise testing, that kind of stuff. Just more algorithmic type test generation algorithms as well. So we're kind of trying to head in that direction. There are definitely lots of challenges, especially with the Oracle problem. Like, how do you know that while you're exploring the system, that what it did was correct?
What's the right answer?
What's the right answer?
Yeah.
So we've tackled that quite a bit, made a little bit of progress here and there, but it's definitely one of the top challenges. But even with all those challenges in mind and kind of still existing, just having this ability to autonomously explore any application is very powerful, because then we can start to build in these simpler algorithmic type test generation mechanisms on top of that.
Yeah. Yeah, no, that's really cool. Yeah, so you guys actually started going after some of the test creation side of it, and one of the things we were looking at is we were looking kind of after, once we got into the regression side, trying to clean up a lot of our activities post-feature creation and value delivery. That's kind of where we've been focused on, and relying on our test, like our test case data history, our test case history, defects that were generated, and that. But yours is actually walking, is it walking the code set too?
No.
Or is it just walking the UI?
It's walking the UI.
It's just walking the UI, okay. All right. Very cool. What else? Is there anybody that, okay, well, who's the skeptics in the room? Come on, there's got to be some skeptics in the room that either you haven't started it because you don't believe it, or you haven't started it because the boss hasn't told you to, or the boss hasn't given you the money to. One of those three things. Probably the last one. Yes. Probably you haven't got the money from the boss because you want to go do it.
No skeptics, seems like.
What's that?
No skeptics here today.
Yeah, skeptics, or bosses didn't give them money to go do it.
So no skeptics, but so this is part of what we call as innovation in a company. But so let's say when you want to win the businesses, for example, what many companies here do, for example, in 5G, you have to deliver the features as fast as possible and get to the market as fast as possible. And yeah, maybe if you invest in innovation like this, then you will be able to win 6G in the future, but surely you will miss the competition in 5G. So that's the biggest problem. So we don't get the money and the people and the time for that.
Yeah, no, that's a real issue, right? Is it's one of those things. How do we try and show our bosses the potential value of this, and could it free up our time to go work on the future feature sets and get more value back into the business that way? It's a tough one. It's a tough sell.
It's always difficult, right? It's always difficult, like fighting against the technical debt. Usually what they like, adding new features, that's it.
Yeah.
Right?
Yeah.
I think it requires some sort of maturity from the organization.
Well, you know what? There is something to be said there. It is, you know, if the leadership believes in strategic thinking, that there's going to be some amount of capacity that they hold back for strategic, even for science projects, because this started off in our organization as a science project too.
So I don't know whether I call myself skeptic or not, but definitely what I have seen, or what my feeling is, that currently, and I think your example with this matrix of systems or combinations and choosing the right ones to test, I think that's a pretty good example where I think it's pretty clear that in those kind of problems, AI could help or can help us even right now. But these are quite specific problems, and I think right now, at least for me, somehow the feeling was that there are very specific problems where AI could help. However, the learning curve that we have to do to be able to apply AI is too high. So compared to the problem that we are going to solve, it's only working still in a larger scale. So in a usual size projects, usual size problems, even though the problem would be suitable for AI, but it's, yeah, the learning and the setup costs and all the other things around that, it's currently too high. And I think this will change, and maybe this was a reason why this graph might be okay. And I think the other big area would be to solve some very general problems, like generally testing and all these things. But this Oracle question and then how to define the value is much harder. I don't think that there will be too much big success in a very close future. So I really feel that we will better be able to find those small and focused problems where AI could help.
So to your point, I want to tap into one of the points that you were talking about, because this slide here was intended to really get folks thinking, not from a job perspective, right? Our testing jobs really consist of a whole bunch of different tasks. There's a whole bunch of different tasks that we do. So, you know, the title of this thing is thought-provoking. Oh my gosh, our testing jobs are going to go away. I'm not saying that. What I'm saying is, think to all of the tasks that you do in your job, these things, and then add AI to that task. Would it help? Would it help you? Would it help you do that task quicker, faster? Forget about how it gets done right now. If I've got X and X is my task, what happens if I add AI to that? I mean, that's the mindset that we should be in. And I'm actually going to talk about that tomorrow, so you guys get a preview of that. It's what task am I doing, and what happens to it when I add AI? Now, the next part of that is, the next point on that is, yeah, it could be a pretty heavy lift if we're the ones asking ourselves that question, and then we're expected to go do it. Because I already said, I don't think any of us have data scientists on our teams, right? So those of us in the room that come from large organizations, I'm with Dell Technologies. That was the biggest technology merger in history. We had an analytics and data science organization in our business. They weren't doing anything with engineering. Once I found out that we had that organization, I was able to enlist them. But before that, we started going to third parties that had that expertise and bring them in. So the first step is, you get yourself in the mindset of, okay, what I do, what are all the different tasks I do, and what could they do for me if I added AI to it? Second question is, who am I going to partner with? to try and do a proof of concept, right? Just do a proof of concept and figure out once you've gone through and prioritized these plus the other 50 or 60 tasks that you guys do, and you want to go do a proof of concept, you want to go get started, then you go ask yourself those questions and what partner can I go in to come in and work on this with me? But it's really important to know which ones you think are going to help you the most first and go after that. If you're coming from because although we're a big organization, our team and our organization doesn't get a lot of money, right? We're in the same boat. We have to make the case for it. And so we got to make a good case for what we want to go after, and here's what our proof of concept is. Here's what we think we're going to get back from it. That's part of what I'm going to talk about tomorrow in more detail, is how can we move forward from it. But at least start off by getting in the mindset of X, the tasks that I do, plus AI. All right.
How do you feel? Another question?
Or I'm ready for another question.
Yeah, let's go for another one.
All right.
What do you think? Or we can bring up another topic. What do you think?
Hi. Not really a question, but I feel sometimes you are trying to solve organizational problems with AI. So the communication gap between dev and testing. And I'm sure you are right, because it's much cheaper to buy a well-aligned organizational unit, if you can, than to achieve the same thing with coaching and development and so human stuff. And it just came to my mind.
Okay, I didn't quite follow the question. Can you ask that?
Okay, so the main motivation for like changing UI selector was that you did not have good communication between development and testing, because the test automation team was lagging behind and could not complete the update. So if you can speed up the feedback loop with adding computing power, then it's much better.
Okay. You nailed something there, because one of the things that we did when we looked at this, all these tasks, we looked at the different tasks that were not necessarily in the things that we do in a sprint, right? The things that we do in a sprint where we're working with our dev and our product owner and our test engineers, and we're trying to figure out the Oracle problem about, is this thing right? That's a highly interactive, collaborative, human activity. We're wired to do that, right? And so what we didn't focus on automating too many of those. We looked at that, we kind of constrained our set of tasks to look at, to apply AI to, as things that were going to buy us a lot more time if we automated to apply the human stuff back into our sprint teams. Does that make sense? Yeah. So because that was one of the things that we want to try and do is what are we humans better at, and what are the machines better at? Because the machines, they don't get bored, right? So they're not going to make the errors. Well, that's when you talk about regression testing and performance and check diffs, that's what that stuff is. Longevity, right? Rote stuff. Let the machines do that so we can go focus on some of the tougher stuff, that contextual thinking stuff, thought tasks, stuff that happens within the sprint team. Yeah, that's a really good point.
Yeah.
That's why I think that's why we're still going to have jobs. Now, you know, on the other end of that, on Jason's side of that, I'm going to be retired by that time too, so I don't know. But I'm more optimistic. I think the strength of us is working collaboratively with folks in that whole value creation piece. We get more time to do that.